Question 11, we're dealing with a sociologist now. So a sociologist wants to determine if the life expectancy of people in Africa is less than the life expectancy of people in Asia. So now look, we've got this table with two samples, right? Two samples. Sample 1, sample 2. So in this case, we're not comparing the population mean to some value, right? We are comparing one sample, the African sample, to another sample, to the Asian sample. We're comparing two samples, two sample tests. They can be a z-test, it can be a t-test. In this case, we know what kind of test it is because we have the population standard deviation, we have sigma. So this is a two-sample z-test. Okay? And just like a regular z-test or t-test, this can take three forms. Left-tailed, or less than. Right-tailed, or greater than. Two-tailed. Let me put tail there. Not equal to, different, something like that. Okay, so I'll show these three differences, and then we'll go from there, right? So, less than. On null hypothesis, if one is less than the other, if the population mean of one is less than the population mean of two. Whoa, sorry. Remember, the null hypothesis is always that they're equal. The null hypothesis is a statement of equality. The alternative hypothesis is the one where we're saying mu1 is less than mu2. For right-tailed, again, the null hypothesis would be a statement of equality. Those two means are equal. There's no difference between the two. But the alternative for right-tailed, for greater than, says that mu1, the population mean of the African sample, is greater than the population mean of the Asian sample. Not equal to. There's a difference. Again, the null hypothesis is a statement of equality. Alternative hypothesis would be not equal to. Now, all three of these can be written this way, or they can be written a little differently. Here's another way to express the same idea. If these two are equal, right? If I subtract mu2 from both sides, won't I have this? Look, if they're equal, right? Wouldn't it be that mu1 minus mu2? Oh, gosh. I'm giving away my stuff. Mu1 minus mu2 is going to equal 0. If they're equal. If the population means they're both 120, wouldn't 120 minus 120 be 0? Right? And in this case, the alternative hypothesis would say mu1 minus mu2 is less than 0. If mu1 is less than mu2, right? If this one was 90 and this is 100, then 90 minus 100 is going to be less than 0, is going to be negative. If this is smaller than that, then this minus that is going to be negative. Or, another way to write this one, same null hypothesis, mu1 minus mu2 is 0, because the null hypothesis says they're the same. The alternative hypothesis, though, says mu1 minus mu2 is greater than 0. It's positive if mu1 is bigger than mu2. mu1 minus mu2 is going to be positive. Or the third, two-tailed, not equal to mu1 minus mu2 is 0. The alternative hypothesis would say mu1 minus mu2 is not 0. It's something else. It's something other than 0, whatever it is. So in this case, we're looking to see if the life expectancy of people in Africa is less than. So we're using this less than test. So the appropriate null hypothesis could be this one, or it can be this one. Both correct. Those are both correct appropriate null hypotheses. But if you think about it, the null hypothesis for all three of these are exactly the same.